Prove the associative law for the elliptic curve, which is good because that makes the elliptic curve to be a group. Then we show how to add a point to itself and 2 points. Okay, we show the inverse. No, I'm sorry, we didn't show the inverse, but we show the identity, which was the infinity, which was 0, which is point at infinity. Okay, just to recap. Okay, so we know like the elliptic curve cryptography is based in the difference of a square and a cubic function in a line. Okay, so it was like this, right? And for this case, we show like something like that. That's one of the forms. And a point to itself, suppose this point 1, and we want to add this point to itself. We draw a tangent line. This has to be a tangent line. It crosses here, right? And it reflects here. And this reflection is 2p1. And this reflection, well, if this is the reflection and take this back, that is the inverse, so then it's 2 minus p1. Okay? This is adding a point to itself. Okay? It's a tangent. This is a line, ax plus b. And these are this part. Okay? Well, we showed that, this point, adding a point to itself. If we want to add point 1, and this is point 2. I will get rid of, I will work in red, okay? It will be a line, okay? And it's gonna cross somewhere, somehow. So it's gonna go like this. So because this is P1, this is P2, and it's crossing here, there we go. This point is P1 plus P2, and this point is my inverse, P1 plus P2. Okay? So the blue is adding 1 point to itself, the red is adding 2 different points. This is P1 plus P2, this is 2P1 plus 1. Adding a point to the infinity. Adding a point will have another point right here. I will call this point 3. Okay? And then I will add the infinity. So I go to the infinity, but because the infinity is very special, the infinity is equal to the point at infinity or 0. So it's gonna go all the way down, right? And then eventually arrive here. Okay? This will reflect here, right? So this is my negative, this is the inverse. And then if I go back, this is P3. So therefore, P3 plus the infinity is equal to P3, or P3 plus the point at the infinity is equal to P3. So therefore, infinity is our identity. And if we have an identity, then we have the inverse, because this is the inverse, this is the inverse, this is the inverse, because take me back to where I start. Okay? Now, this is the general part. Now, what is important for us is the determinant, is the singularity of the elliptic curve, the discrimination. The discrimination has to be different than 0. Discrimination has to be different than 0. Why? Okay. Because if it's not equal to 0, that means that we have some function like this and like that, and at this point is not differentiable. This will not be an elliptic curve. As an example, this one is not an elliptic curve because whatever is here is just 0, 0. This is the discriminant. The discriminant will be 0. However, y squared equal to x cubed plus ax plus b. Yes, this is an elliptic curve, and this elliptic curve looks like something like that. Oops. Like that. We can work with this one, but we cannot work with that one. So that's the conclusion, but we will the discriminant and singularity of the elliptic curve.